Hi, I'm KG from KG Sonics. Today we're looking at a broken Korg Delta. We're going to repair it using an audio probe. So, first place to start is always what's wrong with it. This keyboard, the string section's working, the synth section isn't. Any of you who know this keyboard know it's got two sections, strings, synthesizer. The strings are all sounding really good. But there's nothing out of the synth section whatsoever. Absolutely nothing. No matter what controls we set, no matter what settings we've got anywhere, we just can't get anything out of the synthesizer section. So obviously it needs some repair. We're going to be using an audio probe to trace the audio through the system to try and find out where it stops and then identify the faulty components. A quick word of caution, obviously these things are mains voltages. If you're not comfortable with working with mains voltages present, then just don't do it. To have an audio probe, you have to have the machine live. I'll show you how to do that, but you can't do it if you're not comfortable with the idea of lethal voltages being present. So the first thing I'm going to do is turn the machine off. Then I'm going to lift the panel up. We're going to take this board out. We're going to try and get to the bit we need to get to. But before we do that, let's just ask ourselves, where do we start? So we've got this keyboard, it's got string and synth section. As we said before, the string section's absolutely fine. But the synth section isn't. So what we're going to do, we need to actually firstly look at the block diagram. Always, when you're repairing keyboards, download the service manual. The service manual is going to give you so much help. If you look at the block diagram of this keyboard, you can see the architecture is very different from modern synths. The way this one works, it's got a master oscillator at the top of the structure, which produces all of the sounds. And then we've got divide down circuitry, which produces a fully polyphonic synthesizer from that master oscillator. So what that immediately tells us is if that string section's working, the string section must be derived from the master oscillator, and it is. So that means the master oscillator is working. So that's a whole section of the synth we don't need to look at. It's functioning perfectly, and if it wasn't, the string section, you wouldn't get a noise out of that, or you'd get a weird noise out of it. So that's quite helpful. We can move along the block diagram. We can go past the top octave generator, go past the driver and keyer. If the driver and keyer wasn't working, you wouldn't get a sound out of the keyboard. So we know that's working. We're looking at the mixer next. Well, the strings at least are making it through the mixer. So I'm going to look at the first exit from the mixer and entry into the voltage controlled filter. And it's at this point that we need the schematic diagram. So what we're going to do, we don't need the schematic diagram, but it's a massive help if you've got the schematic diagram. Because all we can do is just trace the audio path along the circuitry. There's two ways you can use an audio probe to chase an audio path. You can do it from the output jack, which is the final audio stage. So we're going to chase it from there all the way back. Or you can do it the other way. You can take it from the sound generating stuff all the way through to the output jack. If you've got a digital keyboard, it's generally the digital to analog converter where you'll start to get the analog sound out of. If you've got an analog keyboard, it very much depends on the architecture of the keyboard. That's why it's really worth having a look at the schematics and the functional block diagram, so you know what's likely to work, what isn't. So what we're going to do next is we're going to take the panel off, we're going to have a look inside the keyboard, we're going to set it up so we can work on it live, and then we're going to use this audio probe to go through each individual bit and see where we can see if we can find which component is at fault. So looking at the schematic diagram, we need to try and find out which circuit board has got the filter on it. Well, it's the one directly underneath the filter controls, surprisingly enough. So what we're going to have to do is we're going to have to take this part of the panel. We're going to have to unscrew all the components on this panel. We're going to have to take these supporting screws out. There's two by the cutoff frequency, there's four by the signal generators, there's two by the envelope generator, and there's one by each one of the switches down here. So we need to take all of those screws out. We then need to take off these nuts. You can just pull the caps off the potentiometers and the sliders, and then we take these two nuts off the pots. We're ready to lift the panel and have a look inside the machine. Keep these two nuts on these pots for the time being, because that's the only thing that's keeping it, stopping it from falling into the keyboard at the moment. So what we're going to do is lift the lid and then take that out. We're going to be using an audio probe to check the audio path of this synth to try and find out which of the components is faulty. So what is an audio probe? An audio probe is basically anything that takes a signal and amplifies it so you can hear it. So what we can do with one wire is we can probe the audio path of this synth and hear whether or not there's actually a signal present, and we can then see at what point the signal dies, at what point in the audio path is the problem. So to do that, what we need to do is we need to ground one side of the audio probe. The audio probe has to be connected to the synthesizer's ground, otherwise it won't complete the circuit. An easy way to do that is just to take an output or an input and grab the ground off the jack plug for that. Obviously, you can also grab it anywhere there's a ground on the circuit. Sometimes that might involve soldering something. It might involve attaching a crocodile clip to a voltage regulator's heatsink or something along those lines. I find it's just easier to take the ground off the audio probe, to take the ground off the jack of anything coming out of the synth. So once we've got that, we've got our audio probe here. This one is set up so that we can hear the output of the synthesizer, which at the moment is dead, and also hear the output of the audio probe. So we've got our ground, we've got the tip, which I've got connected here. So we've got this tip connected to this wire. And so what we're going to do now is just probe the circuit. If we look at our schematic diagram for a second, that audio path, the output of IC8 goes into the band pass and low pass filter mode switch. That's a double pole, double throw. If we turn this board over for a second, we should see that underneath that we've got our synth here. If I just play any key, yeah, so we've got audio coming out of that switch. Okay, well that's good. The other thing I've built into this is an attenuator. If your signal's too loud or too quiet, you can just damp it down. That's useful when you're probing, as we will later on, things like transconductance amplifiers, which have much lower signal voltage that they will handle. So you won't be able to hear it unless you've got this thing ramped up. Another quick bit about audio probes for 1 second. You've got you can make one out of a crystal earpiece very easily. All you do, one side to ground, the other side is your probe wire, and all you're doing is you're grounding one side of it and then you're listening in that. These things are largely indestructible. The downside is you can't really hear the quality of the audio. So sometimes where you've got a subtle problem, like a bit too much distortion or something like that, this thing's just not going to cut it. To demonstrate this, I'm using something that you can hear as well. Another quick bit about safety. I've got basically an empty ice cream container over this mains transformer here. This synth was built at a time where safety standards were a little bit different. It's got mains exposed voltage on live terminals at the back. If I were to touch that, it would give me a nasty shock or kill me. So that's why I've got this over here. It means nothing can fall on it. It means I can't accidentally touch it while I'm working. And it's just a nice little reminder that I've got some dangerous voltage present. So, moving on. Going along our schematic, we know that switch is working, and we also know we've got a signal there. So there's nothing wrong with this synth up to this part. The problem's got to be after this switch. So let's have a look at it. If we trace it down the path, the audio is going to go into pin 13 of IC10. Okay, so this synth uses operational transconductance amplifiers in its filter circuit. So we've got to identify where is the filter. Well, it's basically made of gain cells from IC10 and IC11. So we're looking at IC10 first. If you follow that audio path, you'll see it goes from the low pass mode switch through resistor 118, the 47k, and then into the inverting input of the transconductance amplifier IC10, which is an LM13600, and then it goes out to pin 9 for the output. So if we probe pin 9, we should expect to hear a sound. So let's have a look. Pin 9. Now the way that the pin out conventions work on that, you'll see this chip's got a little red dot. Some of them will have a little indent or something like that, but they'll always have pin 1 marked. Pin 1 is the top of the chip on the left hand side. Then it goes down to pin 8 and then across, so that pin 9 is opposite pin 8. If you've got the chip oriented this way, this is pin 1, this is pin 8, this is pin 9, this is pin 14. So what we're going to do is we're going to probe pin 9. Let's have a look. So IC10, we've got pin 9 here. Here we've got a sound. Right, okay, well that's encouraging because that means obviously that part of it's all working. Looking along, what happens next? It goes along to the next gain cell of that, which the output of which is on pin 8, according to this part of the schematic. So we're going to have a look at that. It goes into the inverting input on pin 4 and comes out on pin 8. So pin 8 we know is the one on the bottom left, bottom right rather. Turn that down a little bit. Alright, still got no filter action there, but we've got audio. Okay, so having a look at this again, we've got the next IC along is IC11, the second part of this filter. We've got the audio coming into the inverting input on pin 13, exiting as an output on pin 9, going into pin 4, coming out on pin 8. So let's have a look. Firstly, let's have a look at the output on pin 9. Nothing. And if we have a look at the output on pin 8, nothing again. Okay, so that would tend to indicate to me that we've got a problem with IC11, the LM13600. Now, you can't get they don't make the LM13600 anymore, but they do make the LM13700, which to all intents and purposes for us is a drop-in replacement. So it's quite easy to get that chip these days. You might have to get the surface mount version and do an adapter for all the dip sockets, but the chip is still available. So the through-hole version of it's very easy to get as well. Even if they stop making it, there's so many of them around. There's no difficulty in getting hold of it. So we're going to stop there. I'm going to swap that chip out and see if that's fixed the problem. Okay, so I've swapped out what I believe is the full-teeth LM13600, which is IC11, for a new LM13700. I've got this audio probe set up so that it will play any audio from the output jack as well as from this probe as well. So let's have a look and see whether that's worked. So there we have it. Korg Delta fixed using an audio probe. If you've got any questions, drop them in the comments. Okay, hope that's been useful. See you soon. Bye.